For today, we are going to be dealing with the forces. Our topic is going to be forces. Then specifically, we are going to be concentrating with the Newton's law of motion. The Newton's law of motion. Okay, so the first Newton law of motion states that a body continues in its state of motion unless compelled by an external force to do otherwise. Okay, what we are just saying is that if something is moving at 20 kilometers an hour, then there is nothing that is going to disturb it. That thing is going to move for 20 kilometers an hour unless it is compelled by an external force that is going to change its direction. Okay, so that's the first Newton law of motion. Okay, then the second law of motion now is saying that force is proportional to mass and acceleration of an object. Okay, so what we are saying, it is summarized like this: force is equal to mass times acceleration. Okay, so we are saying that if a body has got a certain mass, then if we increase the acceleration, the force that is being exerted by that body is going to increase. But if we decrease the acceleration, the force is going to decrease. Okay, then we have got another law, that is law number 3, which says for every force there is an equal and opposite reaction for that force. Okay, for every force there is an equal and opposite reaction for that force. For example, if I'm standing here, then I'm exerting a force that is going downwards. There is a certain force that is equal to the one that I'm exerting downwards that is going to uprise from below, so that I will be balanced. I will be able to stand here. For example, if I'm exerting 40 newtons, then the ground is exerting also 40 newtons back towards me, so that I will be standing at the position that I am. Okay, then the application now, we have got an application for seat belts. Okay, this is the one that is going to represent us in relation to law number 1. We are saying that whenever we are having a seat belt, then we are moving within a car. What is happening when I'm in a car? When the car is 180 kilometers per hour. Okay, so whenever I hit a tree, what I'm going to do is that I'm going to continue with that 180 kilometers per hour. But that seat belt is going to recover that 180 meters per second force or kilometers per hour force, so that I'll come to a balance. So this one is the external force that will stop me from going to the 180 kilometers per hour. Then we have got this one, which is used for the IVF in clinics. For example, the intravenous fluid, for example, the drip that is used within a hospital. Okay, this one we are saying that within the drip, a drip like this, there will be a certain mass. Then there is a force of acceleration that is forcing the liquid that is within the drip to go this direction. So if we increase the distance of the drip, we are increasing the acceleration due to gravity, thereby also increasing the force for the liquid, so that it will be able to interact with the force of the blood pressure that is going to be within the human. So the drip is forced, the IVF, the intravenous fluid, is going to be forced to pass around the body, distributing sugars. Okay, then we have got what we call, for example, in sport, during swimming, we have got the law number 3 now still responding. Okay, the law number 3 now, we will be saying that for every force that is exerted, there is an opposite reaction force. Okay, so in swimming, we are saying that whenever I'm trying to swim, there is a force that I'm going to put that will make me sink into the water. But within the water, there is a force also that is exerted by the water that will be coming upwards. It is called an upthrust. Okay, then here we now have what we call mass and weight. We have to be able to differentiate between mass and weight. Okay, mass is the amount of matter within an object. Okay, then weight is a force that is acting on a mass. So force acting on mass. Acting on mass. Okay, then units, the SI unity for measuring mass is kilograms, but the SI unity for measuring weight is newtons. Okay, then is mass a scalar or a vector? Mass is a scalar. Why? Because it has got size, it only has got magnitude, but mass does not act in a certain direction. Then weight is a vector. Why? For example, weight is attacked by gravity. So gravity is a force that drops things downwards, so it has got direction. Then in terms of changes, mass does not change, so it's fixed. Then weight also changes because it is not fixed, so it changes. Why? Because the change in gravity also brings a change in weight. Then in terms of the measuring instrument, this one we use a beam balance. Then this one we use a spring balance. Okay, so let's find out that how is mass different from weight here. Okay, calculate the mass of a man with 60 kgs. So calculate the weight of a man with 60 kg. If a man has got 60 kgs on earth, you will be having those 60 kgs even on the moon. But here now on the earth, we are now calculating weight. Weight, we are saying force is equal to mass times acceleration. Then weight is also a force which is equal to mass, but our acceleration is now represented by g, by gravity. Okay, so we are saying the weight of this person is going to be 60 kgs by our gravity. We are having gravity on the earth, that's 10 meters per square second. Okay, this one is going to be 600 newtons on earth. Okay, then we go on to the moon. To the moon, we go on to say force is equal to mass times acceleration. Our force is going to be represented by weight times mass times gravity. Then we have got our mass, the same 60 kgs, by our acceleration, that's 1,5 meters per square second. Then we get the total for this multiplication. I'm no longer sure, but that will be in newtons. You can just use your calculator. After you use your calculator, you put the exact figure. That will be on the moon. Okay, so we are saying a person will be weighing less on the moon compared to on the earth. Why? Because the gravity and the force of gravity on the moon is lower than that on the earth.